So good morning everyone. In this video lecture we are going to learn about basic logic gates. We have three basic logic gates: AND, OR and NOT gate. So first of all we will cover AND gate. So this is the symbol of AND gate. We have two inputs A and B and one output Y. We can also have multiple input AND gates. So we are having only two input AND gate for this lecture. And this is the truth table of AND gate where we have two inputs. If both the inputs are 0 or any of the input is 0, we will get a 0 output. And if both the inputs are 1, we will get a 1 output. We will verify its operation with the help of the logic circuit. So this is the logic circuit diagram of AND gate, and we have designed it with the help of a diode. So here I am supplying a plus 5 volt power supply through resistor to these two diodes, and one end of these diode we will connect the input. So we have two inputs A and B. So you already know, if you forward bias a diode, the current starts flowing through it. So this is the basic principle of a diode. This is a diode symbol. So this is the P side of diode and this is the N side of diode. If I connect plus 5 supply, a positive supply to the P side and negative supply or negative end of the supply to the N side, this diode will get forward bias and it will start conducting. The current will start flowing from P to N side. And if I do opposite, if I connect negative end of the power supply with the P side and positive side with the N side, it will get reverse biased. It will not conduct. And even if I connect plus 5 volt here also, plus 5 volt here also, still it will not conduct. Why? Because both the ends will have same potential. Like this, if I give plus 5 volt here also and plus 5 volt here also, so there is no potential difference here, so current will not flow. At both the ends are at same potential. We already know that current flows from higher potential to lower potential only. So this is the basic principle which we are going to use in this logic circuit. So here we have two inputs A and B, and this A and B can be anything from 0, 0 to 1, 1. So now in this diagram we have applied 0, 0 to both the inputs A and B. And you can see the P side of the diode is connected to plus 5 volt supply and N side of both the diodes are connected to 0. So what will happen? Both the diodes will get forward biased and a current will start flowing from this power supply to A and B terminal. So as all the current is flowing towards A and B, we will get 0 at the output. So here you can see in the truth table, when both the inputs are 0, 0, we will get a 0 at the output. Next, if any one of the input is 0 and another is 1, same will happen. Whichever diode is 0, suppose this is 0 and this is 1 now. Now what will happen? As this diode is forward biased, all the current will start flowing from power supply towards the terminal A. And as this diode is not forward biased, because we are applying logic 1 or plus 5 volt here also, and here also we are applying logic 1 or plus 5 volt. So it will not get forward bias as there is no potential difference across P and N terminal. So it will not work. Only this diode will work and all the current will pass from power supply to A terminal. We will not get any output at Y terminal. So we will get a 0 here. So I will write 0 in the truth table. Now what happens if both the inputs are 1? If I also make this 1 or give it a logic high or plus 5 volt supply, what will happen? Now there is no potential difference across the two terminals of diode. At P side also plus 5 and A side also plus 5 or logic 1. So no potential difference. So they both will be reverse biased only. They will be reverse biased, and we know when diode is reverse biased there is no conduction. So current will not flow towards this side. All the current will flow towards the output and we will have a 1 output, logic high output. So in this way we can understand the working of AND gate circuit. We can also design the same circuit with the help of transistors. So here you can see we have given a plus 5 volt supply to transistor 1 and 2. To the base of these transistors we have applied our input A and B, and the output of these transistors from this point we can name it as A. Okay, so this point A, the collector of the transistor, is connected to the base of the third transistor. Okay, so similar way transistor also work. If we give 1 to the base of the transistor and we have already applied the VCC at their collector, so if we apply 1 to the base, this transistor will get on. It will enter into saturation mode. Okay, and if we apply a 0 here, it will remain in cutoff. It will not work. Okay, so what will happen? Let's see. If I apply a 0 and 0 to the base terminal of both the transistor T1 and T2. Now what will happen? As there is no current towards the base of these transistors, they will remain off. They will remain in cutoff. So as they are cut off, they will have a high impedance and they will not allow the current to pass towards this direction. Okay. So current will not pass towards the ground. It will remain here and we will have a voltage drop across R3, and a current from here will be applied to the base of the transistor T3. So at this time, transistor T3, as it is getting a current at its base from this point, it will turn on. It will enter into saturation. So as it enters into saturation, a current which was flowing from plus 5 volt to R5, and it will, as this transistor is on, it will allow the current to pass through it. So current will pass through it towards a ground terminal, and there will be no output at this point C. We can also name it as Y, as we have mentioned in our truth table. So at this time Y will be equal to 0 only. So we applied 0, 0 at the input and we are getting 0 at the output. So this verifies our truth table. Now if any of the input is 0 here also, that transistor will remain in cutoff. Okay, and if a transistor is in cutoff, it will not conduct. It will not allow the current to pass through it. Suppose here we have 0 and here we have 1. We have applied 1. Now this transistor is off, but this transistor is on. Okay, but as this transistor is off, it is in cutoff, it will not allow the current to pass through it. And we will get all the voltage drop here, and a current will start flowing from point A towards the base of the transistor T3. This will make the transistor T3 on. It will in saturation mode, and it will allow all the current to pass through it towards ground terminal. So at the output side, we will not get any output. We will get 0 only. Okay, so for these two entries, when any of the input is 0, we will get 0 only. What happens when both the inputs are 1? So when both the inputs are 1, we are applying current to the base of both the transistors. Okay, so both the transistors will enter into saturation mode and they both will become on. This will also be on, this will also be on. And when they are on, they will allow the current to pass through them towards ground terminal. So we will not get any voltage drop here, or this will be very small voltage drop which will not be able to help this transistor T3 to enter into saturation mode. So it will remain off. Now this transistor will remain off. It will enter into cutoff mode, and as it is cut off, it will now not allow the current to pass through it. So as it is not allowing the current to pass through it, so current will pass from R5 to output side. Okay, and we will get now a 1 output here. So when both the inputs are 1, 1, when both the inputs are 1, 1, we are getting a 1 at the outputs. So we are getting a 1 here.